Okay, so now we're already set up with our first tool here. I got some lubrication right over here. We'll end up needing that. I might have to get something a little bit different as well. But we've already programmed some stuff up, so let's go ahead and use the program. So we've already done program. Now we want to go to run, and I can just start, and then, oh, it even tells me load tool number 1, a 187 diameter bit. I happen to know that that's what that was. And so now that I've loaded that, then I'm just going to go ahead and hit the go button. Now, if you'll notice, this thing is moving on its own, which I absolutely love. And it's going to go ahead and put me at the very first point in which we're going to be drilling. Now, what I'm going to do is fold these handles in so I don't end up hurting myself. But it's exactly at the position it's supposed to be. So what I'm going to do is just do a trial run. And the reason I do that is because, look, I can screw up. So let's turn this on, adjust my RPM a little bit, and I'm going to bring this down. And all I'm going to do is make a mark in here. Next. 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 And next. Okay. So why am I doing that? Well, the reason I'm doing that is 100% is so that I can actually verify what I'm actually doing. Okay, so I can verify a few things. I'm going to go over here and grab my calipers. And I can also grab my drawing as well. And I can lay this down. And remember what the bolt circle was. Oh, okay. The circle here is supposed to be 5.197. So let's go over here. And let's look at this. 5 point. Okay, so it is just a mark, and I'm kind of lining it up. But darn it, if I could not, I believe that that's going to be 5.197. Look, that's what I was supposed to have. That's what I actually have. So yeah, that's great. Now the other pattern was 45 degrees from there, and that bolt circle was 2.121. So I'm going to go over here and measure between those. And it is very believable that that's 2.121. So I have just verified that. Now, the next thing I could do is this on center? So how can I figure that out? Well, the first thing is, how can I figure that out? Oh, right here. This right there should be in the center. So if I go over and I put my caliper right about the center, I don't even care what the value is. I could go right over here. Does it line up the same? Okay. Man, it is darn close to the center right there. It may be a smidge off, but that is believable, but that is exactly where it's supposed to be. So left to right, I know my pattern's on center, and that is great. Now, what's another one? Oh, this one right here is a perfect example. I'm going to go ahead and move this to right about there. And I'm going to bring this over to here. Oh, it's a little harder to actually do on that edge. But I can do it like this instead. And look at that. That is right there. So basically, all I did was I put a tiny little mark in here. Would you see it if I didn't do this? Well, yeah, you're going to see it if I have to move it. But at the end of the day, I just verified that my program was good. And it's believable. Now, usually speaking, my rule of thumb is it's going to be really, really right or it's going to be really, really wrong. I don't have any really good edges to measure from, and I'm just measuring dimples. So if it looks pretty darn close and it's believable, go with it. But usually it's going to be off. And usually where I find one of the biggest problems that I have is I've accidentally not compensated for my my tool. What do you mean by my tool? Oh, yeah, this tool right here. I forgot to do that 100 thousandths offset on that. And I'm like, wow, this is 100 thousandths off. How can that happen? Well, just because I made a mistake, and that's exactly how that can happen. But since I know that I'm okay, I'm going to go ahead and start this program again. So I'm going to go program. Actually, no, I'm not. I'm going to go run, start, go. I got to be careful. Those handles, if I leave those things out, man, they're going to hurt. And I already know where this thing is going to drill. So I'm going to add some oil here. And as a matter of fact, it looks like I'm out here. So I actually moved some of my stuff over. I have a tight shop in here, and we're going to oil that up. And then what we're going to do is just turn this back on, make some adjustments here. Now, what I'm doing is setting the stop so that all my center drills are going to be the same. I'm going to go, Go. And it's cool, I already left the mark, so I know exactly where my center mark is going to be. Now, the other cool thing is keep in mind that when I go to actually do the other one, I don't have to re-verify my program because I already verified the program. I can just go ahead and roll on. All right, there's that one. There's that one. Come on, you can do it. There's that one. Okay. Go ahead and turn that off. We got to turn that off. Why? Well, we got to change the tool. So I'm going to go over here and look, that's done, right? That is done. Watch this. I hit go. Oh, look at this. Load tool number 2, 257 diameter. Oh, thank you for reminding me that my diameter changed. That's kind of cool if you put that into your program. It just kind of helps you to keep things a bit straight. I'm going to drop that down to give me a little bit of clearance. But I want to be careful because it tells me to load this. Then I'm going to hit go again because, yes, I did load that, and now it's going to go to my position. In this case, that would have been the incorrect hole to drill there, so I got to be careful of that. I'm going to go ahead and turn this guy back on. All right, there's that. Make sure it's clear. One of the things that's nice about working with aluminum, it's like butter. And yeah, I could be going faster, but there's no reason to tear up my tools or my part or anything like that. Okay. I'm going to hit go. Look, load tool number 3, 3125. All right, so what are we going to do with that one? So that one, and I didn't even bring it out, but I'm behind you right now actually looking in my toolbox that I should have already done. And I'm going to be finding my 5/16 18 tap. Now, again, there may be some people out there like, ooh, power tap, that's not smart. Yeah, that's fine. Okay. Yeah, that's not smart. But honestly, it's productive, and that's what I'm going to actually do now. So load tool number 3, then go ahead and go. Now it's going to go back over to my position right here. Now, should I be doing something like putting in a countersink part? Yeah, I could do that. In this particular case, I'm just not going to do that. I'm going to go ahead and fly through this. I'll probably do that operation later. But really, this is really informative / hey, what's Mr. Waters doing with this stuff? And that's why I'm doing it like this. So just bear with me on that. I'm going to go ahead and lube my tap. I'm going to turn it on. Okay. 700, I'm at 80. I'm going to speed that up a little bit. All right. Make sure I have plenty of room over here. And I'm going to come down. And I'm going to go. Make sure I don't run out of threads on my tap. Go in reverse. Oh, and that's a beautiful thing. Go to my next one. Make sure my tap is lubed. Same process. All the way down through. Now, can you do this with any tap? The answer is no. This is a spiral point tap, and what it essentially does is it takes all of the chips and it forces them down into the hole. And so that normally might be a problem if it's a blind hole, but in this case it's a through hole, so I'm not terribly concerned with that. Because again, all those chips are coming directly out of the bottom. And the last one. Almost slipped right there. Okay. So now what do we have? Well, we have something awesome. We have 4 tapped holes, and that was really quick. And guess what? These things are straight as can be. They're straight because my mill is all straight. One of the things that you didn't get a chance to see is that The head is all trammed in. The vise is all lined up. So there is absolutely no reason that this would be off at by any stretch of the imagination. So now that we're done, we hit go again. Oh, load your next tool. Okay, so don't mind if I do over here. I've already done that work. We're going to go ahead and try to get this tool in. Look, I don't have enough room, so what am I going to do? Well, simply I'm going to make room. I'm going to bring that knee down so that I have a little bit more room. Make sure that tool is nice and tight right there. Switch back over into high range. I'm going to go ahead and turn the first one. Turn this on. I'm going to slow that drill bit back down. Not getting into the drill speeds and stuff like that with you. That's not what this little lesson here or this little video is about. But I've already done the calculations and I know exactly what to expect for aluminum, so I'm in good shape. All right, so this right here is pretty much all we're going to do. And we're going to turn that off and we're going to hit the go button. Oh, load the 1/2-inch tool diameter. Okay, so this is where it's going to get a little fun here. We're going to shift gears. This is a little bit longer of a video now that I'm realizing this. But we're going to do this last little bit here and kind of go over how I'm going to get the accurate depth on the hole. So in this case, I am actually going to be using I'm going to be counterboring, but I'm not going to actually be using a counterbore tool. Okay, so what do you mean? Well, counterbore tool actually has a pilot, and it helps with the lateral forces as it's going down to stay straight in the hole. And in this case, I don't have one, but what I do have is a 1/2-inch end mill. Okay, now this end mill is going to have those forces. It's not going to have this point to where it's bringing it straight down through the hole. Rather, what it's going to do is it's going to want to push and pull. And I don't want to put that into my drill chuck because that's not what it's designed for. So I got this 1/2-inch end mill actually in a solid tool holder because I use it for other things. This 1/2-inch mill gets beat up actually quite a bit. So what I'm going to do is use it in conjunction with this with what I'm doing here in order to get my hole depth. Now, when I take a look at my hole depth, I got to go back over and check my hole depth, and it's 0.315. Okay. So I have to go 315 thousandths. So let's watch this. I'm going to bring this up so I get a little bit more room here. Okay, I'm going to bring it about this far off the part, and I'm going to go ahead and stop this at 0. Now, you haven't seen this, but there's a dial over here, and it's at 0. Every line is a thousandths. Now what I'm going to do is bring this down and hold it, lock my quill. Take this guy, stop, bring it all the way up, okay, and make it tight. So if I push on this, it wouldn't go down because it's on the material, and it wouldn't go down because it's right here at 0, 0. Now, I'm going to take the table and bring it up 315 thousandths. 1, 2, 315 thousandths. Okay, 315 thousandths there. Now, this is the beauty of it. When I go down, look, there's a gap here, and you'll never guess what size that gap is. Oh, it's 315 thousandths. Perfect. Turn this on, get it all the way down, lube up our surface. All right, there's our counterbored hole. Next. Treat it just like drilling, but remember, it's not a drill, so we got to be careful with that. Okay, program is done. Now, before we take this part out, okay, I'm already set up. I've already lined it up. Everything is good. I've done all the holes, but we're going to check that hole depth, okay? The reason we're going to check the hole depth is because if it's off, it is so easy to fix it right now. But if the hole depth is is off and we pull it out, we have a nightmare of a time to set this thing back up, to get everything lined back up to make it go. So I'm going to check all that stuff off camera, and then I'm going to move on with those parts.